Hey everyone, welcome back to the Retro Hack Shack. I'm your host, Aaron Newcomb, as always. This video is part of a series of videos that we're calling DOScember. Get it? DOScember? So for the month of December, a bunch of retro YouTubers are going to be doing videos featuring DOS and PC related topics, and this is my addition to that effort. You can just search for the hashtag DOScember on YouTube, or I'll put a link to the playlist down in the description below. Lots of great people are joining this effort, so I think you're really going to love it. When I think of DOS, I think of the IBM PC 5150. That is the first PC, the original PC that IBM put out. But until now, I haven't had a monitor that kind of matched that era computer. So I've used different things. I've used my Tandy 1000 monitor, which worked okay. I created an HDMI adapter that piped video out through HDMI to an HDMI display. But I really wanted to get a monitor of that era so that I could complete the setup. So something like a 5153 CGA monitor or a 5154 EGA monitor.
You know, it's true what they say, the world is a carousel of color. If you're among the thousands of people switching to an EGA color graphics adapter each month, you should already know that the exciting new graphics standard can display 16 colors out of a total of 64 available.
There's only one problem, though. These things have been becoming more rare as they break down and people aren't able to repair them. In fact, just looking at some recent eBay deals that have happened, these are sales that have actually been made. You can see the cheapest one here is $200. It doesn't even have the buttons. I'm not even sure it's a 5154 by the looks of it. And this other one that was working, that was sold for $550.
Well, I was at an estate sale recently and I happened to find a 5154 EGA IBM monitor. And I was really glad to see it. There was only one problem. It wasn't working, which isn't really a problem in my case. I kind of like to get things that aren't working and fix them up. But this monitor was in particularly poor condition. There was Sharpie written all over the thing. It looked like it had seen better days. It had been bumped and bruised along its lifetime. And when you turn the thing on, it didn't power up at all. There was just nothing. So I took a chance and I got the display for about $30 because it, like I said, it was not working at all. And I figured worst case, maybe I could try to adapt the thing, put in an LCD screen inside, keep the case, but have a HDMI input on it instead, which I thought would be kind of interesting. But really what I wanted to do was fix it up. Well, let's see if I can do that today as I try to fix up this old 5154 EGA monitor to complete my IBM PC ensemble, if you will. So let's do it right now on the Retro Hack Shack.
Okay, so I already know this does not power on, which is one of the reasons I bought it. Because if it powered on but the screen didn't work correctly, or if it powered on and there was fuzziness or weird signals and things like that, that would be, for me anyway, that would be harder to troubleshoot. And the irony is that, you know, up until a few years ago, you know, if something didn't turn on, I figured, well, that's it, end of story, right? I would think that would be harder to repair than if it turned on and worked, sort of. But in this case, it just doesn't power on, and that means there's probably something going on in the power supply, likely capacitors or a fuse that's blown. But I don't think it's the fuse, and here's why. We'll find out. But when I turn this on, it does come on, and it does a little doing thing. I don't know if you've ever turned on an old CRT like this, you know what I mean? It goes boom. And I think that's maybe the flyback transformer that does that. I'm not really sure. Maybe we used to call it warming up. You know, the tube is warming up. It would go doing, and then it would zzz, and it would work. Anyway, you can hear that when I turn it on, but then nothing happens and it doesn't stay on. It just does that really quickly and then nothing. So
So I'm going to see if you can hear this maybe if I put my mic close to it. And I think what's happening is to me, that signifies that there's probably a short in the power supply somewhere, either a blown cap. Like I said, maybe I don't think it's the fuse, because if the fuse was blown, I don't think I would get anything. So I'm hoping it's just like a reefer cap or something that I can take out and get this thing working again, but I won't know until I take this apart. Now there's these two little plastic pieces here on both sides of the monitor, and I think those screws have to come off first. I'm hoping they'll just come off this way with a little effort. Looks like they're coming up. Yep, and there is a screw underneath there. And unfortunately this one cracked. So I'm going to go ahead, it hasn't cracked all the way, so I'm just going to go ahead and put some super glue on that right away before it falls all the way off. Maybe I can keep it strong enough to last for a little while. That plastic is pretty brittle though. And on the bottom here, it looks like there's 4 screws. This obviously holds this plate on. And then there's a couple more screws on either side here that need to come out as well. Okay, let's see if this will come off now. Oh, yep. That actually had kind of a nice crack to it. I need to untie this cord, but that has a nice crack to it. I'm hoping that means that nobody's been in here before. Anytime you hear a screw, take a screw out and it goes crack when it first starts to turn, or in this case, the plastic kind of went crack when I took it off. A lot of times that means that nobody's been in here before you have, so it's kind of interesting. Okay, I'm gonna put this back up. Be careful not to touch any of the underside of the board, because I don't know what's in here yet. I think this is the power supply because it's in a cage. Just in case there were some big caps here, I'm gonna be careful not to touch the back of this right now, just in case, since I did have it plugged into power before. Those caps can retain a charge for a while sometimes, and then if you touch the bottom of the board and short out the cap, you'll get a nice little bite there. I think if I'm careful, there we go. So just looking at this, the way this is constructed, definitely typical IBM overkill here. Now you notice the high voltage they have marked there, which is really nice. You don't usually get that on the inside of a CRT, but they've definitely marked that out. And then, having the power supply inside its own cage like this, again, a little bit overkill for what is typically done with a CRT, certainly shortly after this. And then if we go around to the back here, you can see everything's really packed in nicely. No space is wasted. And then over here, I'm not sure what's on this side actually. I'm not sure what that is, whether that's more of the high voltage transformer stuff or what that is on that side. I'll have to figure it out. But it's clear that, based on where the power goes in, this is the main power supply. This is where I think the problem is. So got to get that off. So as I'm doing this, I'm being careful not to get too close to these high voltage areas of the tube, just because they still could hold a charge for a while. They should bleed out relatively quickly, but you never know. Always better to be safe than sorry. The other thing I'm noticing is this right here. So unfortunately, this is not a screw, it's a rivet. And there's probably some more of these around. I can see one that's kind of falling out on the other side, but this appears to be holding this metal case together. So there's screws that are holding the box in place, but then the box itself, the inside, you can't get to those without, I bet, taking these rivets out. So we'll have to do a little bit of rivet removal, but they are pretty loose actually. I can kind of move them around with my fingernails. So maybe those won't be too hard to get out. And there's a grounding bolt on this side. They just took this cable, spliced it, and then grounded it directly to the chassis here. That's going to be a little tough to get out. I think I can do it. But you just need to be really careful of this yoke back here. You don't want to break that off. I would take it out, but I think in this case I'm going to leave it on for now and just see if I can work around it carefully. Okay, that finally came away. But what's interesting is the way this is connected. It's almost built more like a computer. I guess that's typical of IBM. But they've got these connectors here, here, and here for the power. So all of those are a really interesting way to connect a power supply to a CRT monitor. Now the way that you drill out a rivet, if you've never done it before, is you take a look at the head of the rivet. There's kind of usually a flat part, and it can tell you basically how big the shaft is, because you want to pick a drill bit that's slightly bigger than the shaft, not necessarily bigger than the head of the rivet, definitely bigger than the shaft, and you're just going to drill through the top of this. Now the complication here is that these rivets are not tight. I can wiggle them around with my finger. So what I might do, so the drill method might not work with these. So what I might do is pick the loosest ones and just see if I can clip them off, because they seem to be fairly thin metal. And if I can, then that'll be a little bit easier than drilling. So let's see if I can get under there. That's not working. So try the drill method, see how it goes. There, you can see it kind of came free. I don't know if you could see on the picture, but it came free and the rest of the head started spinning, and that's when you know you're through. So the one thing you want to be careful of is these metal shavings. Definitely want to get all those off of the power supply at the end of the day. You don't want any metal shavings making a connection inside there that would short out your board. All right, so I'm just going to unplug this little jumper cable. Make sure I don't lose that. Then there's just one more screw here that needs to come out. Then we should be able to see any sort of damage on the underside of this board. So here's the mains power coming in, and it is soldered directly to the board. So that's going to have to get removed. Shouldn't be a big deal. Okay, so here's the main power supply. And like I said, I checked the fuse. I can see that it's still connected. If that were to 2.5 amp, if that were to blow, you would know it. But just for completeness, I'll pull out the multimeter, see if we have continuity. But like I said, since I heard that little twang when I turned it on, I'm pretty sure the fuse is not blown, because if it was, you wouldn't even get that. You'll also see this sometimes with power supplies that that are driving a fan, for example. If you're having a problem, when you first turn it on, the power supply will, the fan will come on just like for a second, and then it'll shut down. And that's basically the power supply going into short circuit mode or short circuit protection, where it won't come on fully. And so you just get that little brief burst of energy coming through the power supply, and then it shuts itself down really quickly. So let's just go ahead and test the fuse. Yep, no problem with the fuse. But there are two Rivet caps that definitely need to be replaced. And the other thing I see, but I'm not sure that it's actually leaking, a couple of things. Number one, these caps here are definitely bulging. Let me see if I can turn this up so you can see. These caps are definitely bulging. There's a lot of black gunk. I don't know if you can see it. I need something to point with. There we go. Maybe you can see that now. There's a lot of black gunk around here. I don't think that's leakage, though. I could be wrong. Let me know what you think in the comments, whether that's actual capacitor leakage. It doesn't seem like it to me, because I can see some on the side of some of these other caps. So it's possible that that's leakage, but it's very dark and doesn't look like traditional leakage to me. Let me know what you think. I'm definitely going to be replacing these two caps, and I'm going to be replacing the Rivets caps. It's also kind of dark around here, so I'm definitely going to be measuring these resistors over here to make sure they're still okay. There's another kind of dark area over here, and so I want to be checking out these. I don't know if they're MOSFETs or perhaps they are voltage regulators. I definitely want to be checking those out as well. This discoloration could just be from the heat that these things produce. So I'm not really sure I'm worried about that yet, but I'm definitely going to be taking a look at, like, you know, this big old guy here, that big old resistor, just to see if anything's blown. So one of the things I just noticed on the board was, as I was looking at it, is this resistor over here. At least I assume it's a resistor. No? It says C, so it must be some sort of capacitor or choke or something. It's right over here, and you can see that the top has come off of it. Now, I don't know whether it blew or whether there's a problem there. I don't think I did anything to cause that. There's no black marks or anything, but it's definitely got a little chunk out of it, like someone took a bite out of it. So that's going to get replaced. The one nice thing about this board, I will say, is if you take a look here, I don't know if you can see that, it says C44. And the great thing about the way this is marked is if you just turn it around, it's very easy to see where that component is on the back side of the board. So this is, whoops, get it in frame. This says C44 right here as well. So it makes testing it really nice. And a lot easier than other boards where you have to kind of try to guess where those legs of those components are coming through.
In addition to the great markings on the board itself, there's also a Sam's photo fact available for this monitor, which covers things like schematics, lists of parts, troubleshooting, and voltage that would be expected at certain junctions. And it was invaluable to me in troubleshooting this monitor. Now, none of these capacitors have vents at the top of the capacitors, and it's at this point I realized that this capacitor, C23, was all dimpled and showed obvious signs of leakage.
Okay, so here's that capacitor that was, I noticed was kind of dimply. As you can see from the top, it really doesn't show any signs of damage or wear. So just looking at this visually from the top, it really didn't look that bad. However, from the side, I don't know if you can see the dimpling on the resistor. That's a clear indication that something is going wrong. And in fact, when I took it out and looked at the bottom, now you can see a close-up of, you know, what that actually looks like in terms of there's some definite leakage coming on here. So if you see these capacitors that have this flat top that doesn't have the little notches built in, you may want to check those. But you can see the difference here in, let me get another one, in these two. The reason I'm showing this one is because I don't know if you can see the hot snot here. I just wanted to show the difference in the hot snot versus the leakage. You can see here that this is clearly, there's even a crack right here in the plastic packaging that's at the bottom. This one just has the hot snot and doesn't show any signs of green or white corrosive liquid coming out of it, but this one definitely does. So I just thought what I would do is test this one, and then I pulled out all the other medium size caps as well. And as I pulled them out, I labeled their rating, voltage rating, as well as their capacitance. And then I thought I would just go through and test, and any of them that are out of range, more than, say 10% or so out of range, I'll definitely replace with working ones. In fact, I'll replace any of these with new ones if I have the value. If I don't have the value, then I'll and they are working, I'll just go ahead and put them back so I can test this board out further. But for now, I do have a small meter that does test for capacitance. So I'm going to go ahead and put that in capacity mode, and I'm going to test out this capacitor, it's supposed to be 2200 microfarad. So let's just go ahead and test this out and see what we get. Hopefully you can see this. Yeah. So it's supposed to be 2200 microfarad and we're getting about 40 microfarad. So this capacitor is definitely dead as a doornail. Yeah, it immediately comes back at nowhere near the rated value. So we'll definitely be replacing this one, and I'll see if I have the values to replace the other ones. Now, the other thing that was suspect in my testing was this diode, because I wasn't getting, it looked like when I tested it in circuit, which isn't a good way to test diodes, but it can give you an indication. So when I was testing this in circuit, I was seeing voltage no matter which way I tested the diode. And diodes are only supposed to allow voltage to pass one way. So I pulled this out to test it, and I'm just going to show you how I do that. I put my meter into diode mode. If your meter has a diode mode, it'll have that little symbol for diode. And then on a diode, there's usually a marking. The marking typically, not always, but almost always, indicates the cathode end of the diode. A diode, kind of like a battery, has a cathode end and an anode end. In this case, in order to test this diode, I would put I'm in diode mode, I would put my positive lead on the anode end, or that's the positive end, and my negative lead on the cathode end, that's the negative end. So hopefully I said that right. Anode equals positive, cathode equals negative, typically. And as you can see, if I touch that, I'm getting a reading. This is going to put just a little bit of voltage through the diode to test what comes out. And you can see that the forward voltage reading is 0.4. This will typically be 0.4, 0.3, 0.4, 0.5. If it's more than that, if it's a lot more than that, especially, then that might indicate something bad. But 0.3, 0.4, 0.5 is all typically okay. Now, if I reverse this, I shouldn't get anything. The reading shouldn't change. When I tested this, when I first pulled it out, I swear, I was getting some reverse voltage going through this diode. I'm not getting it now, so maybe I was doing something wrong. But this is a 30-year-old diode at least, so I'm going to go ahead and change it with an equivalent one that I found. But just in case you ever wanted to test these, you really should pull them out. If you find one that you think is suspicious, pull it out and test it. That's the way you do it. Now, those very large caps actually tested okay. Turns out the bulge at the top appears to be some sort of resin or epoxy that was used to seal the capacitor. So what I did to test them further was I took them down to the makerspace, which has an LCR meter, which measures inductance, resistance, and capacitance. And it also will give you the ESR rating of that particular capacitor. ESR stands for equivalent series resistance. And if that value is too high, then it means these capacitors are bad. However, if that value is okay within tolerances, then these capacitors should be just fine and I can put them back in the board. As it turns out, both the capacitance and the ESR rating for these capacitors turned out just fine. Okay, so it's time to test the board and see if those new caps make any difference. Before I do, though, I just want to say a quick note about safety. This setup I have right here is convenient for testing, but it's not very safe if you don't know what you're doing. So pretty much all of this board from here over is AC high voltage, AC high voltage. So there's 120 volts coming in. A lot of these other areas are 60-ish, 62, 68 volts AC. So if anything that I touch or set down or short circuit is going to cause a problem. So you have to be really careful when you're doing this. Now, I've got this set up to the switch here, the front switch, because you need that to power things on. I could, stick a paper clip in there or something, but again, I'd rather use the power cords that came with it if possible, so I don't screw something up. And I also have this chassis, this board is grounded by screwing in the ground connection that comes in from the wall when you do that, it makes connection with the chassis, basically all the chassis here. So even this little ground connection here gets connected here. So ground is delivered to the whole system basically, instead of directly by running a wire from the ground that's coming in from the outlet to this board. It actually is just screwed into this terminal, and then that gets spread out throughout the whole chassis via the metal that's used to build this up. So that's why I have this little lead here, because without this, there's no ground actually getting into the board. In fact, I still need to screw in this screw right there so that ground can actually make its way into the board. Okay, now what I want to test is when I had the bad caps in here and I was probing around to see what was going on, I noticed on this 12 volt power regulator that it wasn't putting out 12 volts, and what was going into it, which should have been, I think, something like 16 volts or something, was actually only 0.4 volts. So what I want to test now is, before I put this all back together, I just want to make sure that I've got at least the 12 volt situation figured out, and I'm getting 12 volts from there. If I do, then that's going to make me think that maybe things are good enough on this power supply that I can put the power supply back in and test everything else out. So now, go ahead and hook this up to power. Just doing one last double check to make sure that everything is out of the way, so I don't hurt myself. I'm going to go ahead and turn this on. Let's see, ground. Nope. So this 12 volt regulator might be bad. Or the diode might be bad.
2 weeks later.
So at this point, it's actually 2 weeks later because I had to order some more parts. Here's what I did. In troubleshooting this, I don't know if I went over this before, but in troubleshooting this is the main transformer here that outputs 4 or 5 different voltages to the various pins that go into the main board of the monitor. Essentially, I'm not getting any of the correct voltages on this side of the transformer. The input side, I am getting the higher voltages. It's about 163 volts after it goes through the bridge rectifier. So I am seeing that on this side, but on this side, I'm not seeing any of the 12 volt. There's a bunch of different 54 volts and different voltages. So the capacitors didn't solve anything, unfortunately, even though one of them at least was definitely bad. So that left me kind of wondering what was going on. So I went and asked my friend Jim if he could take a look at the schematic, which he did. And we started troubleshooting. And what we found is that it didn't look like the transformer was starting up, basically. It's actually 2 transformers. There's this big one here, and then there's this little one over here. And it didn't look like this transformer was kind of getting started. Basically, in the circuit, there's a couple of transistors that look like they kind of start up the transformer. I'm not an expert, which is why I asked my friend Jim to help me with this. But that came down to us tracing back various components and testing them all. And eventually we got to these 2 transistors here. There's a T6 and there's a T5. I believe it's over here. Luckily, these are marked on the back, which is really great. But T5 checked out okay, and T6 did not. So here is T6. And we took this out, and you can look up how to test the diode very quickly on Google, but this one was not passing any forward voltage in any direction. So this one was definitely bad. And what's tricky about these, and why sometimes you have to go to the trouble of testing every resistor and every capacitor and every transistor, even on these power supplies, is that when they fail, a lot of times with transistors, they don't fail in a way that is obvious. There's no marks on this. It doesn't look like it was in bad shape, but it's on the inside of this die, it certainly was not working. So that's why it took me a couple of weeks to finally order some more transistors. And I finally got those in the mail. These are high voltage power transistors. So I'm going to put this back in to replace this one. And then when I go back, I'm going to look for those various voltages on this side. If I get anything at all, look for those voltages. If I'm still not seeing the voltages on this side, then there's probably something else going on still on this side of the board. The other thing I found out as I was testing this, I thought I had found some bad resistors. I was taking a look at these resistors down here, and I didn't recognize the values. And I just wanted to see if they were, what the value was, if they were reading what they should be reading. And so I just started taking some measurements with my meter like this. And I don't know if you can see, it basically comes up as 0 and then resets and comes up as 0 ohms again. And same thing for these resistors over here, I believe. There was 3 of them. They were gray in color. And it just didn't, I took that to mean that these were open, that they weren't actually putting any resistance in the path here. And in actuality, what it turned out to be was my meter, these were so low resistance that my meter wasn't able to detect them. 2 of them are like 0.52 ohms, and the other one I think is 0.1 or 1 ohm or something like that. So they're just really, really low resistance values, and my meter wasn't able to pick those up because it didn't have the resolution. So what I did was I took these out and took them down to the makerspace with the high precision meter that we have down there, and sure enough, I verified that their values were correct. So the transistor that I'm replacing luckily I can see what orientation it went in because it was up against this heat shield. I put a little thermal compound on this, the back of this transistor, and it's held on with this little clip. It's kind of an interesting arrangement. Instead of being screwed in, although there's a place here where you could put a screw on this little heatsink. But in this case, it's held on with this little clip that goes in one side and then you clip the other side and it holds the transistor in place. So it's kind of cool. So I put a little thermal compound on there. I'm going to put this in and solder it in. All right, so I've got this back connected to just the power switch. I've got it plugged in, got the ground connected, and I'm ready to test. I'm going to be looking for 12 volts on that 12 volt power regulator. Okay, it is on. And yes, there is 12 volts. And not only do I have 12 volts, but I'm hearing a little power supply hum that I wasn't getting before. I'm going to go through and check the SAM's SAM's computer facts on this power supply or on this monitor and see if I can test the other voltages and just make sure they're okay. Then I'll put it back in and do a test on the monitor. Okay, so I think I've got everything wired up. So it's time to do a smoke test with the rest of the high voltage and the main board. So this should be interesting. Hopefully it's not interesting and we just see some fuzz or something, but we'll see. Here we go. Oh, I heard the degausser and I thought I heard something on the screen.
And that didn't fix it either. So at this point, I was getting a little frustrated. So I went ahead and decided to take a look at the main board. So for that, I had to disconnect the video board on the other side of the monitor and very, very carefully disconnect the anode cap from the tube. And if you don't know what you're doing with that, I suggest you don't even bother. But there are safe ways to disconnect that without harming yourself. Then I could lift the main board out and go ahead and start testing. I decided to start by focusing on these transistors and ICs, seeing that those were getting probably a lot of activity and were possible suspects for faults. I also wanted to focus on any area of the board that showed signs of heat. So these resistors, you can see the board is slightly discolored there. So I wanted to focus on those areas of the boards as well, because where there's heat, there's probably a chance for a fault. And looking at the bottom of the board, you can definitely see where heat has changed the color of the board. And in fact, in testing this, I did find one bad transistor that I had to replace on the main board as well. But before putting this back in and doing another test, because it's so much work to connect everything, I went ahead and tested every capacitor, every resistor, and every diode. Luckily, everything else seemed to be checking out okay.
We should be getting a test pattern. Let's see what happens. I've got a light. Oh, it seemed like I heard the screen kick in. It went, choo. Okay, Okay, I'm not seeing the test picture, but I'm definitely seeing something on the screen. And there is static on the screen. I don't know if you can hear that. But that's really good. You can't, I'm sure you can't see it on the camera, but I can definitely see something like some very faint static back there. But maybe making progress? I don't know.
1 week later.
Okay, so I've had a bit of a breakthrough on the power supply, and I wanted to share what I learned in case somebody else is also having this problem. So here's where we're at. With the power supply plugged into the main board of the monitor, when I measured the voltages, I wasn't getting 6.3 volts, which should be coming out of these pins down here. So I took this off, I went back through, I found what I thought was a bad resistor and a bad diode. I replaced those, and I didn't hook the power supply back up to the main board, and I still didn't have 6.3 volts on the board, but I had all the other voltages, or at least, all of them were a little above what they should be because I wasn't plugged in. There was no load and I wasn't plugged into the main board, but that's okay. I could still see voltages on those. The 6.3 volts, which actually drives the heater of the CRT, was not present. And luckily, let me show you what that looks like. So the way that I was measuring this was I would connect one probe to ground, and then I would use the other probe to measure the voltages. And it's going to be hard for me to do this on camera, but if I measure that 12 volt regulator, for example, I'm seeing exactly 11.92, which is what I expect to see. There's other higher voltages over here. So for example, if I measure this pin right here, you'll see that's very high voltage right now, 242, and that's a little high. When I connect it to the board, that goes down to the proper voltage though, because there's some load on it. However, when I measure where the 6.3 volts is supposed to be, which is over here, it was just kind of getting readings that were nothing, or jumping around, really nothing going on there. And so what I didn't realize, and this is because I think Dave Jones over on EEV blog would call this a trap for young players.
Hi, I wanted to show you a feature in modern digital scopes that can be a real trap for young players if you don't know what you're doing. And
in this case, I'm the young player here. So what I didn't realize was that, these connections right here, this connection and this connection that are coming back to the transformer are what's providing that 6.3 volts, but it's an isolated ground. In other words, it's isolated from the main ground that's coming in from the wall. And I didn't realize that. And so I'm measuring, it's kind of like measuring one side of a battery without touching the probe to the other side of the battery. You're not going to get any reading. So a user on vcfed.org told me to actually check across this capacitor here, C23, and that should give me a reading if I'm getting the voltage. Again, this is going to be higher than 6.3 because I don't have any load on it. But he said if I check there, then I'm actually using the isolated ground and I should be able to get a reading. So when I check across C23, I get 14 volts. In this case, negative 14 volts, but I could swap my probes around and get 14 volts. So that is exactly what I would expect to see without any load on this power supply. So I spent a week essentially troubleshooting this power supply in, out, removing diodes, testing diodes, checking every single resistor on this board, because I thought that there still must be a problem when it turns out I was just measuring the voltage incorrectly. Now, the good thing about that is I'll realize that next time, hopefully, and won't spend all that time. So I learned the lesson the hard way, but it was a good lesson learned. And maybe if somebody else is trying to repair a power supply like this from a 5154, they will, hopefully this will help somebody that's in the same situation I was, so you don't spend weeks of your time troubleshooting a non-existent problem, essentially. Also, I wanted to share what I'm doing for these, where the rivets were in the power supply, in case anyone is trying to do this. As other people have suggested on a few places, I found these sheet metal screws, which are the same size as these other screws, these case screws, that actually go into the plastic on the case. I found that these actually fit into this hole after the rivet was taken out just perfectly. So I went to the hardware store. I took this one with me as a reference and came up with these short sheet metal screws, pointy tip screws that I fit in here actually perfectly and hold the case together after I've taken out those rivets. Okay, I've got everything hooked back up well enough for a test, I think. I think I've got everything connected. I'm just going to turn this on and see what happens. Fingers crossed. Okay, so far, same as before. Oh, look at that. That's new. That's a really good sign. Okay, we may have life here. Okay, let me just hook up the 5150 and turn it on. Maybe this is working. Oh, that looks good. Yes, that's awesome. So this is the post or the BIOS from the EGA video card I have hooked up. So this is looking really good. Let me zoom in just a little bit. Look at that. This is fantastic. I wasn't expecting it to hold. I figured there'd be at least some fine tuning I need to do. But it looks like it's working. Let's let this thing boot up and I'll load up a test pattern. All right. Let's just check out the color swatch here. Oh, look at that. That is awesome. So I don't know how much flicker there's going to be on camera, and I apologize for that, but this is fantastic. Very clear. But man, that's perfect. This monitor is working. And just to make sure, let's load up a game and see what it looks like. Looks like it's loading. This may take a while. It's connected to a 5150 right now, so... Oh. Wow, that looks great. EGA colors. I may have to mess around with a little bit of the hue and the color saturation levels on the various colors, but that's looking perfect. Nice. Oh, look how slow that is on a 5150. It does run, but I wouldn't want to play it like this. It's really slow. It was not meant to be played on a 5150, but the colors look great. So I think what I need to do now is go back to the test pattern and see if I can stretch this out vertically just a little bit. So I'm just going to fire up Check It, because they have a nice grid pattern that I can use to make sure the video is in the right aspect here. Mode 0EH. I thought there was a bigger one. There we go. That's the one I want. Mode 10H. Interesting. So I'm going to see if I can just tweak the size of this a little bit. There we go. That's what I was looking for. Just to make it a little bit larger. That looks about right to me. So I'm going to leave it just like that. So I'm so happy that this is actually working. I think the only thing left to do is to clean up all of this awful gunk that's all over the case. So we'll do a quick cleaning and get it ready so that it will be looking perfect to sit on top of the 5150. All right, let's clean this thing up.
I started by removing all of the stickers and tape and sticky residue that was on this particular monitor. Interestingly enough, it appears this particular monitor was used by the US Navy. Luckily, this sticker came off pretty easily, as well as the tape that was on the other part. However, it left some pretty nasty, sticky residue that I knew would not come off with soap and water. Then I used a paper towel to dab some orange oil on the areas where I needed to remove that sticky goo. I did that because I didn't want it to run all down the monitor and get inside. I let that set for about 20 minutes and then came back and it cleaned right up. One of the side effects of doing this, however, that I realized was that orange oil works really well for Sharpie marker. I guess I had never figured this out before, but it literally cleans it up even better than isopropyl alcohol. With the outer shell removed, it was time to give the back of the case a good cleaning with soap and water since there's no electronics in there. And of course, that includes cleaning all those little holes with a toothbrush. However, for the front part of the monitor, I didn't want to remove all the electronics in the CRT tube, so I went ahead and cleaned that with just some regular Windex. Once that was done, it was time to move on to my tried and true method of using baking soda to clean up the remaining marks, scratches, and scuffs that were left on the case. I put this light cloth around the monitor and tucked it in under the plastic so the baking soda wouldn't fall into the electronics because that would have been a pain to clean up, and that worked pretty well. Last but not least, I cleaned up these textured dials. Ironically, even though this is one of the smallest parts of the monitor, it's probably the one that gets touched the most often, that is the power button. So I really wanted to give these dials a good scrub and get into all those textured crevices. So here's what the monitor looked like originally, and here's what it looks like after the cleaning. So without further ado, I can finally reveal what this system looks like once it's all put together. Doesn't it look great? It's just the way it's supposed to be with an IBM monitor atop this original IBM PC. When I'm working on a project like this for months, I get a tremendous sense of accomplishment when I finally see everything come together and it's working properly. And I think that, above everything else, is what keeps me interested in retro computing.
Well, if you couldn't tell from the video, I am extremely excited that I was able to get that monitor working. I worked on it for over 4 weeks. In fact, I had that monitor and was working on it while I was doing my last 3 or 4 videos, at least, on the channel. So I had been working on it, ordering parts, working on it a little bit more, and I cannot tell you how excited I was when that display popped on and I could actually see what was written on the screen. It was so exciting. It's always fun to bring old technology like that back to life. And it's not only fun for me, but now I can bring that whole setup along with me whenever we can start doing live events again to a festival or fair or something where people can come and experience the nostalgia of seeing a system that they may have had or may have used when they were a kid and be able to run the same programs that they ran back then. Never ends hearing those comments from people as they use that technology. And I know I'm certainly going to enjoy it. Do me a favor, if you wouldn't mind, if you're still listening and you like this episode, hit the like button or click subscribe. That would really help me start to grow the channel and get more feedback, which is what I'm really looking for. So leave me a comment. Do you like these types of videos? Would you rather see reviews or some other content? Let me know, and that will guide what I do in the future. You can also, of course, as always, support me on Patreon. Become a patron for $2 a month, and you get access to me, behind the scenes footage. If there's ever ads on the channel, which I'm not sure I'm going to do yet, but you'll get ad-free and early access to content, as well as being able to vote on upcoming material that you'd like to see. So take advantage of that as well. Thanks for watching, and we'll see you next time.